Hi everybody, this is Jim Kemp of 705 CNC. Hey, I wanted to introduce our new RPiDNC box to you today. As you can see behind me, we've got both a VF2 and a VF5. The VF2 is relatively new and it connects to our building network and it makes transferring Gcode files to it pretty easy. It's just a matter of connecting to the network and doing a drag and drop. The VF5, on the other hand, there's two options. You either use a floppy drive or you use a serial port, and both of those had problems. The floppy drive, which it came with, this is the original. We don't have floppy drives anymore. I don't anyway have a computer that has a floppy drive, so transferring it using floppy drives is not an option. So I did like everybody else, and I bought one of those virtual, you replace this guy, and it's actually installed over here. And you can use a thumb drive to transfer files back and forth. But the thumb drive was a pain in the neck. It was always not where I was, so finding it and transferring files was just a major pain in the neck. You also had to remember to type the name of the file every time you wanted to transfer the file. So that was a pain. Trying to type it on a membrane keypad is not the ideal solution. So, we did like everybody else again and started using the serial port. And having a dedicated PC, it takes up a lot of bench real estate. The keyboard gets grungy pretty quickly. The computer's never on and booted up. There's always this delay waiting for it, getting it connected to the network. It was just a major pain in the neck. So basically, out of frustration, the RPiDNC box was born. So this is based on a Raspberry Pi, single board computer, which is inside, and it's a quad core 1.5 gigahertz single board computer. So this thing is pretty beefy in its own right. So let me take you over here and I'll give you a close-up look. Okay, let's give you a close-up view of this Raspberry Pi. So this is a single board computer. It's available, and what we're using inside our product. So it's got the quad core underneath here. It's got Wi-Fi. This is both 2.4 gigahertz as well as the 5 gigahertz Wi-Fi. It's got gigabit Ethernet, which we use, and then on these I/O pins we use the makes a serial connection. So that all gets embedded into this box. So underneath this heatsink is the Raspberry Pi. You can barely see it down in there. There are the Ethernet connectors, and there's our dedicated serial port. So we've got an extra chip or an extra board down in here, our own custom board down in here to do all the interfacing. It's got a really nice, I forget the brand name, Nocha? It's a really good fan, and we control the speed of the fan to maintain the cooling. And then it's got an LCD screen on it with a rotary knob, a couple of push buttons. So it's a lot of horsepower for the application, but not that expensive. So yeah, here's a complete box all ready to go with the cooling fans on it. And it's got a little on-off switch. So basically that's it in a nutshell. It's pretty simple stuff. So let me take you up and actually show it to you on the Haas running. Okay, here we are on the Haas VF5 with the RPiDNC box installed. So this guy just sits up here, sitting at the ready, waiting all the time for files to be downloaded to it. Some other stuff you can do while it's here is you can hit this list button, and it will now go through and print all the old, or show you all the old deprint messages. So anytime one of the programs spits out a deprint message, the box captures it, puts a date and time stamp to it, and puts it into a log file. So this is the index to just let you know how many there are. When it says gibberish, when the machine first powers up, it sends a burst of crap on the serial port, so the box thinks that that's some kind of deprint message. So basically it's kind of nice. I just label it as gibberish, but it tells you the date and time that the machine was powered up. So it's kind of nice to have. So here's a job I was doing, the program number and a little bit of the string from the deprint message. So I can just keep going backwards in time, rotating this, seeing that each time I ran this same program. Here's a warm-up program. That's when it's done. Here's when it started. And then here's the gibberish. So power a little late in the morning on this one when we started, 8:50 in the morning. But still kind of nice to see, you know, when you started. And then now we're into the previous day. So it can just keep going backwards in time. And this will go back for up to 100 of these on the display here. Now they're all stored in the log file that's stored on the box itself. So you can always come over the network and grab the log file and go back as far back as you want. Literally thousands of these can be saved into the log file. So when you're all done, you just press the button and it goes back to its default rest state. So showing you the current time and date, and just because you can, it goes out on the internet and grabs the current temperature off the internet. So this is local for Troy, Michigan, where we happen to be located. So it's currently 43 degrees outside. So just because it's a cool thing to be able to do. So let's go around the back and I'll show you what that looks like. So we've got our Ethernet cable coming down in, and you can see a couple of the blinky lights down in there. Here's our power, so we can click that on off. And here's the serial cable that's screwed in, so it's not likely to come out. So that's it in a nutshell. So now we can go through the process of actually downloading a file, and I'll show you what that looks like. Okay, so here we are on my computer, and I've got a network connection to the box, so hopefully you can see this down here. So this is called the VF5DNC. That's the name of the box on the network. So here are all the files that are on the RPiDNC. So here's the log file, right, that we were looking at a minute ago, and every 20 kilobytes the file is renamed, and these files just keep moving down. So if I open this, let me open this with my editor and we'll look inside of it. So here are all the messages that are recorded inside this log file. So you can see these are the deprint messages in here that are being displayed on the box, but there's a bunch of other messages in here for things that are going on, you know, a new file being downloaded. It tells you the date and time, and yeah, this just kind of goes on and on and on. So good information if you want it. Yeah, so we'll look at this in a bit. This is all these files were uploaded, so we'll look at that in a minute. So let me close that. So the magic directory here is called exfr. That's where you place a file that you want to be copied onto the host. So let me start a new tab in here. So now I've got two tabs, right? Here's the Raspberry Pi. I'm going to open up the exfr directory, which has nothing in it. And then I'll go to my computer and I'll come over here to my NC files. So here's a program that's almost 500 kilobytes long. So that's a pretty big one. Let's pick one that's a little smaller. Here's 44K. And I'm just going to click it and drag it and drop it onto the tab for exfr. So file transfer done. So there is front.nc that's been transferred over to the box. So now we'll go over to the RPiDNC box and see what has happened. Okay, so now we're back at the VF5, and you can see the display is now telling me, you know, a download is ready, front.nc. So the RPiDNC box has detected that the file has been transferred to it, and it is now ready to transfer it onto the host. So to do that, you just come down here and hit the word list programs to make sure you're looking at all your programs. You come down to the word all if you're not already there. You scroll down to all, and you hit on the keypad down here, you just hit receive program. So now the Haas is waiting for data, and we come up on the box and we just hit the download button. Downloading, you see the bar graph going across, it's transferring the file, and download complete. And we look on here and we can see serial receive done. And here is our program 233, the front thing. And here's the program all done, ready to go. It was just that easy, just a few button clicks and the program is downloaded and ready to go. 45 kilobytes, I think that one was. Okay, transferring files back to your computer is just as easy. So back here in the main directory on the RPiDNC, we're going to go to the directory called Uploaded. And if we open that one and double click on it, there's nothing in there. So let's go over to the RPiDNC box and we'll upload some files. So back over on this guy and we'll hit list programs, and you could either have a single program, you could come up on any one of these and hit the send button over here, or if you're on the word all and you hit send, it's going to send all of them. So first let's go to the box that's just sitting in its idle state. We'll hit download. So we'll hit him. So he's now ready to upload files, saying that. So we come down here to the word all and hit send. And you can see it's sending, and it tells you the program number down here, and up here it's telling us that it's uploading. So it's going through the programs one at a time. I'm not sure you can see that. It's going through them, and it won't take it too long to rip through all of these and send them. Yep, serial send done. And up on the box it tells you how many bytes were received, and then it goes back to the idle state, just sitting and waiting. Now if we go back on my laptop though, and we look on here, you'll now see it's changed. So in that same empty directory, it's now full of files. So these are all the programs that came over. So you can open any one of these guys. Open with my editor. And okay, that's a pretty simple one. But we'll open one of the bigger ones here. Here's one 40K. Open with the editor. And just tons and tons of Gcode, just as you'd expect. So that's it for uploading files. The Haas is now completely backed up of all the files that are loaded on it. Okay, last thing I wanted to show you was the proverbial drip feeding. I don't personally use drip feeding, but everybody else seems to be pretty interested in drip feeding. So I've got a really large file here. It's 1.3 megabytes. I'm not sure you can see that on the video, but it's just a three-dimensional profiling program that is just huge, and it for sure wouldn't fit in the memory of the VF5. So I'm going to take that guy and just drag it over onto the RPiDNC. So it's copied it over there already. And now we're going to go over and see what's going on the box itself. Okay, back on the VF5, you can see that it has detected that a file has been dropped into the drip feeding directory, so it's ready to start downloading that. So first we need to go on the Haas and make sure that it's ready for DNC action. So underneath settings, you page down until you see somewhere in here there's something about DNC. Oh yeah, this stuff 115 200 kilobaud, no parity, one-stop bit, X modem, 8 bits. So that's the default setting for all RPiDNC action. So makes it pretty simple. So, oh yeah, here it is. Enable DNC from MDI screen. So that needs to be set to on if it's not already. So now we can come down here and hit the MDI button. And if we hit it again, we'll go into DNC. So now the Haas is telling you it's waiting for the DNC and it's waiting for data. So up on the box itself, we'll just hit the download button. and you can see that the screen is now filled with Gcode, and the box is showing for each blink is one block of data sent, and it's telling us the % complete so far. So now in the Haas itself, we could hit the feed start button, and Haas takes off and starts doing his thing. It's just, you see, just ripping through this Gcode, although it's only 2% complete. So this will just go on and on and on, going through all this Gcode data. Actually, the box itself will finish early, and it will then it downloads faster than the Gcode can be executed, so it buffers it ahead so this guy can finish early, and then the buffer finishes the last of the Gcode. So that's pretty much it. Oh, one thing I forgot to mention during this DNC running is that all this transfer is happening using the X modem protocol. So if there's any errors in the, you get a noise spike or communication error, the protocol will automatically compensate for that and retransmit. So your program won't just stop because of a single error in one line of Gcode. So that's pretty important.